Performing calculations on vectors requires only a small set of rules. For instance, that multiplying a constant to a vector, let's call the vector AB, just multiplies inside of the constant, inside of the vectors towards the components. So CA, CB. Similarly, adding or subtracting vectors, let's call them A, B, and C, D, add and subtracts the respective components. So A plus C, B plus D. Finally, we have these absolute value symbols, which in terms of vectors just mean magnitude. So the magnitude of a vector AB is just the square root of a squared plus b squared and is just a constant. So we can calculate, for instance, a here, which is 3v minus 2w. V and w being defined with 3i minus 5j. I and j being the unit vectors in the vertical and horizontal direction. Minus 2 times negative 2i plus 5j. One thing to keep in mind is that while I wrote all these calculations in this vector form with the two little arrows on the left and right, it's perfectly fine to write it in 3i, 5j, this sort of format with the i's and j's. It means the same thing. And in fact, facilitates some of the operations a little more clearly. So for instance, right here, it's a little more obvious that we can distribute the 3 in the same way that we'd be distributing the c into the vector. So I'd have 9i minus 15j minus 2 times negative 2. Negative 2 times negative 2 is a positive 4i minus 10j. Then we can combine some like terms and end up with 13i minus 25j. Let's see if we can compute some of these other values. So for instance, part B here is asking us whether we can compute the magnitude of W minus V. So B is asking us if we can compute the magnitude of W minus V. Note that W and V are vectors that we know of, so we can write this as negative 2i plus 5j minus 3i minus 5j. And we can perform this subtraction before we perform the calculation to find the magnitude. That is, negative 2 minus 3 is negative 5i, and positive 5 minus negative 5, minus subtracting a negative is the same as addition, so we say plus 10j. Then, the magnitude of this vector is the square root of the components squared and then added together, so we have negative 5 squared plus 10 squared. Negative 5 squared is 25, 10 squared is 100, so we have the square root of 125. And if you feel like going the extra mile, the square root of 25 is 5, so we have 5 square root of 5. For comparison, part C here is asking us the magnitude of W minus the magnitude of V. Notice that this is different because we're computing the magnitudes separately and before we perform the subtraction. Let's see if we get the same value. So the magnitude of W minus the magnitude of V, magnitude of V is equal to, well, again, W and V are their own vectors that we can compute. That's negative 2i plus 5j. We just know what those vectors are, thankfully. Subtract the magnitude of V, which is 3i minus 5j. And again, you can perform the magnitude calculations. That is, this is the square root of negative 2 squared plus 5 squared. And the second one is 3 squared minus negative 5 squared. One thing to keep in mind is that make sure your negatives are in parentheses. That's just sort of a notational thing, but it does tell you that when you square it, and your calculator, when you square it, the negative gets carried along. That is, it's negative 5 times negative 5, so that way it's positive. So we have 4 plus 25 is the square root of 29, and 9 minus 20, plus 25, there should be a plus right there. 9 plus 25 is 34. So we have the square root of 29 minus 34, and notice that that's different than 5 square root of 5. But that often happens because these two values are not the same.